So this is Dr. T, and this is the video on conducting the ANOVA test in SPSS. So here I have another one of the data sets from SPSS sample data sets, and this one is German credit history of sorts. And we are going to perform an ANOVA. So remember, the ANOVA is the analysis of variance of the means of more than two groups. So first, we need a variable that is quantitative in order to conduct the mean. And we also then need an independent variable that's qualitative so that we can get our more than two groups. So we have a number of quantitative variables here. We have duration and credit amount, and then we have actually scale. So those are actually the only three options for quantitative variables. For the qualitative, we have resident length and a bunch of others. So if we were to look at, say, account status, let's see how many groups there are in, how many categories are in that variable. So we have one, two, three, four, five groups in that variable. So we can do an ANOVA test that looks at the credit amount based on, in this case, the type of history, payment history, right? So we have these five different groups, and so we can look at the average for each of those groups, and then do the ANOVA to determine if there is statistical significance as far as the differences are concerned. So to do the ANOVA, we go to Analyze, Compare Means, and this is a one-way ANOVA. And so here's what we are going to be looking at. So we're looking at credit amount for the different history of payment history, I think it is. And that variable is going to be, I think this is the one. So we put the quantitative variable, numerical variable in the dependent list box, and then we put our factor or independent variable in the factor box. And so to for a simple ANOVA, you would just choose choose your descriptive statistics, and those are the essentials. And if you just do okay, that would give you essentially a bare bones ANOVA test, right? So you have your descriptive statistics here, you see the four groups, you get the mean of the credit for each of the four groups, and then you have your ANOVA here that tells you whether there is statistical significance or not. And here we see that the p-value in this case is more than 0.05. So we would actually have to retain the null, that says that there is no statistical significance as far as the differences are concerned. So here you would report that the p-value is more than 0.05, and so therefore the difference is not statistically significant. But by way of example, so let me choose one that should actually give us some difference, and let's choose this variable, residence length, and see if there's a difference as far as the credit card amount is concerned as it relates to the different lengths of residence, the time that you've been living in a certain area. So again, we have the variable, the independent variable here, or the grouping, and this is our quantitative variable that we're going to find the mean of for each of the groups. So let's see. And here we have no statistical significance again. So I'm going to keep looking because I want to find a grouping that does show statistical significance so that I can show you the let me see, maybe account status. I can show you the post hoc test that as it relates to, here we go. So now we see that for this grouping, as far as history, payment history is concerned, there is a statistically significant difference among the groups, right, as it relates to um, the amount of debt. So this is the, as I said, the bare bones of the ANOVA test. You have your descriptive statistics, and then you have the results of your ANOVA that shows that there is a statistically significant difference among the groups. So when you find statistical significance, you then now have to carry out the post hoc analysis, right? So that is where you're going to determine whether there is which groups are different. Where does the difference lie? Is it they're all different, or just two of them are different? What is actually going on? So we're going to get more details about the test beyond stating. So remember, our null hypothesis is that there is no difference, all of the means are equal, and our alternative hypothesis says that there is difference, right? And so that difference could be they're all different, or just one is different from all the others. So there are a variety of options. So we want to carry out our post hoc test, and for that we do analyze again, and we do the comparison of means. And so when we get to this part here now, what we want to do, click on the post hoc. So we are going to basically do the post hoc, and there are different types of post hoc depending on the main criteria for choosing the type of test is whether the variance among the groups are equal or they're unequal. If there's equal distribution, then we would do the Bonferroni test. If it's not equal, then we do the Games Howell. But what we do is we actually set up the test to get both results, and then we'll choose which one we are going to analyze. So when we go to the options here now, so right here where we choose the descriptives, we can choose the homogeneity of variance test. This is the Levin's test that we would do to tell us whether there is equal variances or not, and whether we should be interpreting the Bonferroni or the Games Howell test. So we have our homogeneity variance test. The other thing we want to do is generate a means plot. It just gives us a visual representation of how the means relate to each other. So once we've done that, we could also do the estimate of effect size. That's another one of the post hoc tests that we can do. But we'll just do this for now. And when we click OK, so we've run the test again. So now we have our descriptive statistics here. And this is where we have the results of the test of homogeneity, right? The homogeneity of variances. So this test tells you is whether the variability among the groups are the same or are they different. And remember, it will determine whether we're going to use the Bonferroni for our analysis or whether we're going to use the Games Howell in terms of exploring the differences. And the test of homogeneity is different in the interpretation of this test is different from the way we would normally interpret the p-value, because here the null hypothesis states that there is equal distribution of the variances, and that is the preferred state. So in this case, we want to uh, hold on. We want to keep our null hypothesis. When when we're analyzing the p-value for our t-test or ANOVA or any other kind of measures, we actually want to reject the null. But in this case, we want to keep the null. So we would look here, and we want to have a p-value that is actually more than 0.05, and that will allow us to then claim that the variances among the group are the same. So this is what the Levine's test or the test of homogeneity looks like, right? So we have, this is an imaginary line of possible p-values, and down here in the extreme where it is zero point zero 0.05 or less, that's where the area of unequal variances would be determined, right? So if the p-value is less than 0.05 in this case, then we would have to actually say that the variances are unequal. And so we would interpret the Games-Howell test. If the p-value is more than 0.05, then we would have to assume that the variances are equal, and in that case, we would use the Bonferroni results. So this is mm, the opposite of what we would do for the t-test and the ANOVA and all the other tests. So it's a little bit of kind of an intuitive challenge to understand the homogeneity test. But the idea is that unlike this p-value where we want it to be as low as possible to claim significance, this one we actually want a larger p-value to be able to retain the null that the variances are equal. But the main idea is if this value is less than 0.05, then we would say that the variances among the group it is unequal, and so we would interpret the Games-Howell test, right? So that's what this test tells us. So here we have significance; it is different, but now we want to get more information, and this is where we get the post-hoc test. So we can't use the Bonferroni in this case because the p-value is less than 0.05. So now we go to the Games-Howell, and this is where we look for significance, right? So we see significance here, 0.016. So that is less than 0.05. So what that is saying is that for those with the no debt history, their average payment, their average credit, sorry, is actually different from those with a payment history, and it is also different from those with a critical account. But it is not different from those with no current debt, nor is it different from those with payments delayed, right? And so you can go on and look at all the others. So here we see again significance. Payment current is different from payment delayed, and payments delayed is different from payments current. So these are kind of repeats. So they're taking each category separately and reporting on its difference from all the other categories. So of course there's going to be some repeats, but you want to focus mainly on where there is actual statistical significance. And so those are the ones that you would be concerned about, right? So if we looked at this is the means plot, right? So we see the means for all of the group, the means of the credit amount. So those with the no debt history, they have the highest means, while those with payment current and critical amount, those actually have the very lowest. But if we go to the interpretation of the results of the ANOVA, we see that the no credit history is only statistically significant from the payment current and the critical amount. So they are only statistically different from the payment current and the critical amount. So it's different from these two as well, but it's not enough to claim statistical significance. And one of the ways you can actually look at that and see is because those groups have they're much smaller. So it's difficult to claim statistical significance as far as the differences are concerned when you are comparing some of these smaller groups in terms of the sample size, right? Because sample size determines variability, and the ANOVA test is the analysis of variance. And so if there is not enough as far as the sample size is concerned to adequately analyze the variance, then you cannot state statistical significance. And so that's essentially how you would perform and conduct your analysis of variance. So for your reporting, you would include your table, your descriptive statistics table, and you would of course include your ANOVA results. And you would include the test of homogeneity table. Um, you would not include the post-hoc table, but you may include reporting on specifics of the groups in terms of which ones were different or not, but you would indicate that that is those are the results of the Games Howell post hoc type of test, right? And I did share the video with you in terms of how to conduct descriptive statistics. So in this case, you would also do some generation of graphs for this type of test, right? You would want to show the distribution for the various measures. So if we were to do some descriptive statistics here, we would, if we clicked on explore, and we are looking at credit amount versus, I think, residency. Yes, so residency length, that was the one we were looking for. So if we wanted to show the plots for each of those, right? So here we have descriptives separated for each of the groups, right? Each of the four groups as far as the history is concerned. And then we would have a distribution for histogram for each of the four. And then we have here finally a box plot representation for for each of the different groups. So those are some of the things that you would include in the descriptive statistics before reporting on the results of the ANOVA. Okay, I think this video has been long enough. Bye.